Here's a dimensional analysis question which actually came up in my fluid mechanics exam. So that was the first year fluid mechanics module that I had as an aerospace engineering student. And this is what the question reads. So a wind turbine generates power, which is denoted as P, and that power depends on the rotational speed and the wind velocity, the rotor diameter, the air viscosity, and density, and yeah, that's pretty much it. So what the question wants is to find an expression relating a non-dimensional form of power to an appropriate Reynolds number. So we have Reynolds number and tip speed ratio and d over u. Okay. And maybe I should remove this because then the next part says use rho d and u as the repeating variable. So the question actually gives us a few hints regarding what to actually use and how to solve this. Okay, so let's first of all list all the variables. So let's see how many we have. First of all, we have power. Now, what are the units of power? Well, we know power is measured in watts or joules per second. Okay, so joules is then, if we break this down even further, a joule is basically Newton times meter. That's work. Okay. Newton is kilogram meter per second squared, and then times meter over second. So this is kg meter squared over second to the power 3. Right. So that's the first one. The second one is n, which is the rotational speed. So the rotational speed is, it could be radians per second or second to the minus 1. So whichever one it is, this is going to turn into 1 over second or second to the minus 1. So we can also write this one as kg meter squared s to the minus 3. Okay, and then for the third one, we have wind velocity. So that's the speed of the free stream speed, for example. So that is measured, of course, in meters per second, which is meter second to the minus 1. Okay, so we've done power, we've got n, we've got u. So let's do diameter, which should be pretty easy. So diameter is just meters. Okay. And then we've got two more. We've got density. So density is measured in kilograms per meter cubed or kg m to the minus 3. And finally, we have viscosity. So viscosity, in this case, um, a dynamic viscosity more specifically, this is kg per meter second or kg m to the minus 1 s to the minus 1. And that should be it. Okay, so we have all the variables. Now, what we can also do is we can write this in terms of, without using the SI units, but instead we're going to do it like this. So this one, so power, let's actually write it here. So power is measured in, we said, kg meter squared second to the minus 3. So instead of kilogram, I'm going to write m for mass. M to the 2, instead of m, I'm going to write L for length, and instead of second, I'm going to write time to the minus 3. So we're going to use those instead of the actual units. So then n, the rotational speed is going to be t to the minus 1 instead of second to the minus 1. Then u is going to be meter per second, so it's going to be L t to the minus 1. Then we have diameter. So diameter is L. Then density is ml minus 3, and mu is m, l to the minus 1, t to the minus 1. So those are our 6 variables. So let's write here that we have 6 variables. Right, we have 6 variables. How many independent units do we have? Well, of course, we have 3. So we have 3 units. If you're confused about that, the units are just m, l, and t. So each variable has a combination of either m, l, and t. There's no fourth unit that appears in any of them, right? All of them have a combination of m, l, and as well as t. So if we have 6 variables and 6 units, if we do 6 minus 3, that's going to give us 3. And this 3 means how many pi groups we have. So we have 3 pi groups. So we have pi 1, we have pi 2, and we have pi 3. Now, each group will have one variable that does not appear in any of the others. So the question tells us to use rho, d, and u as the repeating variable. So in other words, each pi group will have rho, d, and u in some form, but it will also have, so each pi group will have a fourth variable that does not appear in any of the others. So let's say that the first pi group, I want that to have power. I want my second pi group to have n, and I want my third pi group to have mu. And this covers everything. So we have 3 repeating variables, rho du, rho du, and rho du. And then the other 3, there's basically one in each, right? We have power, we have rotational speed, and we have dynamic viscosity. So now that we did this, let's actually get to work and find how each set of variables can be combined into something non-dimensional. So first of all, we're going to deal with this, and we're going to try to see how we can combine this into something which is, again, non-dimensional. So this is what we have. We've got power to the power 1. Now, the reason I'm leaving power to the power 1 is because we want, so the question says, find an expression relating a non-dimensional form of the power. So I want to leave power as it is, basically, in the numerator if possible, and instead I'll raise the other 3 to different powers. So this is going to be to the power x, diameter to the power y, and u to the power z. And what I want to get on the right-hand side is something with no units, or a constant, like this. So let's write this in terms of the actual units of each variable. So for power, we have ml squared t to the minus 3. So we have ml squared t to the minus 3. Then we have rho to the power x. So rho was ml to the minus 3, and this is raised to the power x. And then we have diameter d, so that's l to the power y. And then we have u, so that's l t to the minus 1 to the power z. And whatever comes out should have no units. So this is going to be, let's say, m to the 0, l to the 0, t to the 0. That's what you always do. So let's group all the terms. So we have an m here, we have an m here. So the m is going to be m to the power 1 plus x. So because this is to the power 1, this is to the power 1 times x, which is x. And yeah, now let's look at L. So we have an L here and L here. So there's an L appearing everywhere, right? So we have L to the power 2 minus 3x plus y and then plus z. And then times t to the power, we have minus 3 and minus z. So this is going to be minus 3 minus z. And this is going to be m to the 0, l to the 0, t to the 0. And of course, what we do at this point is we compare each power with each power on the other side. So the first one would be 1 plus x is equal to 0, which gives us x straight away. So x is going to be equal to minus 1. Now, let's actually do the last one because it only has one variable. So let's say this has to be equal to this, right? So minus 3 minus z is equal to 0, which means that z is equal to minus 3. And we only have this one left. So this one has to equal to this. So that's 2 minus 3x plus y plus z equals 0. Okay, now in the last one, we can actually replace x and z by what they actually are. So 2 minus, and instead of x, I'm going to write minus 1. So this is going to be 2 plus 3 plus y, and instead of z, I write minus 3 equals 0. 3 and minus 3 cancel out, so y is equal to minus 2. So that's it. We found x, we found y, and we found z. So the first pi group is therefore going to be equal to, um, probably should have written it here as well like this. So the pi group, the first pi group is p power, remember this is to the power 1. Then we have rho to the power x. So rho is rho, obviously, but x is minus 1. So this is rho to the minus 1. Then we have the diameter d to the power y. So y is minus 2. So that's just going to be like this. And I think the last one was the speed u, right? So the speed, this is to the power minus 3. And if we get rid of the negative powers, this is just power over rho d squared u cubed. And if you try it out, you'll see that this here has no units. So this is a dimensionless power, sort of like a power coefficient of sorts, if you want to think about it this way. And that's the first pi group. And we're going to do exactly the same thing with the other two groups as well. So the second pi group doesn't actually have power in it, but it has m, right? That's the rotational speed of the blades. So that's going to be equal to n to some power, which I'll come back to that in a second. And then the repeated variables, or the repeating variables, they have unknown powers once again. So this is rho, d, and u. So what did we use for those? X, Y, Z. Okay, I'm going to use X, Y, Z again, but remember in this case, those X, Y, Z are not the same. So now we just sort of like clear the memory at this point, and we have brand new X, Y, Z, which will most likely be different, and we have to find what they are. Okay? So yeah, and that's pretty much it. So at this point, we say that this has no units. Right, but I said I will look at the power of n. So the question tells us, find an expression relating a non-dimensional form of the power. So because of this, I actually left this power to be to the power 1. And then they say to an appropriate Reynolds number and tip speed ratio n d over u. So, okay, this actually tells us straight away what the pi group looks like. Okay, and in here you can see that n is just n to the power 1. And what I'll do is I'll just put a 1 here, and then I will prove that this will actually turn into n d over u, which is a non-dimensional rotational speed of the blades. Okay, so I'll use the same procedure, and I will show you that the pi 2 group will end up looking like this. So let's do that. We have n, so n was the rotational speed, so that's time to the minus 1. Then we have the density rho, which is mass length to the minus 3 to the power x. And then we have d, the diameter, that's length to the y. And then we have the u, which is lt to the minus 1 to the z. And this is equal to n to the 0 as usual. Okay? So let's take this and let's move it around a bit. And let's see how we can find the new x, y, and z terms. So in this case, we have t here and we have t here. So this is going to be t to the minus 1 minus z, and that has to equal t to the 0. Okay, so it's the same procedure that we applied here, which means that minus 1 minus z is 0, which means that z is minus 1. Let's do that with L. So we have L here, and L here. So this will give us minus 3x. I'll write that straight away. Let me actually write it under here. So minus 3x plus y and then plus z equals 0. right, we can't really do anything with this yet because we have z, but we don't have either x or y. So let's do m. So we have m here, and that's it, which means that x is equal to 0. So we have z, we have x, which means we can find y. So y is going to be equal to 3x minus z. So that's 0 minus z, which is 1. So we have found all of them. We found x, we found y, and we found z, which means that the second pi group, pi 2, is going to be equal to. So n stays as n, that's to the power 1. Then we have rho to the x, so rho to the x, which is rho to the 0. Then we have d to the y, so d to the 1. And then we have u to the minus 1. And look what happens if we rewrite this. So this is basically 1. We can ignore it. This is n d over u. So the non-dimensional form that the question gave us, which is n d over u, is actually what we found out as a result of the Buckingham pi theorem, right? And the third pi group, I won't go through solving this because the question actually tells you what the third pi group is, and that is the Reynolds number. So that is going to be equal to the Reynolds number, which is rho u d over mu. You can try this yourself. You can combine the variables in a similar way and find x, y, z, and you'll end up exactly with this. Okay? And that's pretty much the end of it. So at this point, we found all three pi groups. So the second one was n d over u, and the first one, the interesting one, let's put it this way, or the one we really didn't know anything about, is equal to this. So this tells us that there's a relationship between those three variables. Now, the Buckingham pi theorem doesn't actually tell you what the relationship is. It just tells you there is a relationship between this variable, and this variable. So what we'll do is we'll say that in this case, I'll write it like this. The power, the non-dimensional power, which is this, is a function of the other two. And the other two are n d over u, as well as rho u d over mu. So we don't know what the function is. That's not what the Buckingham pi theorem tells us. It doesn't tell us what the function is. How exactly does it depend on on those two variables? We don't know that. We know it depends on them in their non-dimensional form. Okay, so we found the non-dimensional power, this. Then we have the Reynolds number, and we have the non-dimensional rotational speed. And that is what the question actually asked. So is that find an expression relating a non-dimensional form of power, which is this, uh, to an appropriate Reynolds number and tip speed ratio. So that's what we have. We have that the non-dimensional power is a function of, it depends on the non-dimensional rotational speed as well as the Reynolds number. And that's it. And that's the end of the question.